In the heart of an unyielding digital landscape, a relentless machinery hums, orchestrating the rhythm for 3 pulsating YouTube channels. For 43 days, this intricate system has churned out content without a single touch, a testament to its meticulous construction. This is not a tale of hours spent wrangling with tools or the hefty cost of hiring a team. This is a narrative about an n-step automated process, forged in the crucible of ffmpeg, a powerful command line tool. With this system, you will learn to automate your video production, freeing you from the shackles of manual labor and allowing you to focus on the creative essence that breathes life into your content. Prepare yourself for the heat of the forge, the pressure of precision, and the transformation of raw materials into a polished, automated pipeline. Together, we shall build a system capable of unleashing your creativity, one command at a time. Chapter: The problem in the crucible of media production. Hours are forged into minutes, and dollars into cents. Manual video production, a laborious process of stitching frames together, can consume precious resources, with costs escalating to hundreds of dollars per month in man-hours alone. A broken solution often employed is the reliance on proprietary software, which, while offering convenience, imposes a steep financial burden and restricts creative freedom. This common solution, though seemingly efficient, fails under pressure due to its inflexibility. It limits customization options, forcing creators to conform to predefined templates rather than forging their unique vision. The failure mode is evident in the lack of control over output quality, rigid workflows, and limited compatibility with various file formats and hardware configurations. Those who have ventured down this path will attest to the frustration of being shackled by software that hinders rather than facilitates their creative process. The siren call of convenience has led them astray, obscuring the path to true mastery over video production. It is time to break free from these chains and embrace a new anvil ffmpeg. Chapter: The materials in this forging. Will be shaping a video production line using ffmpeg, a robust and versatile toolkit born from the crucible of open-source development. Our materials are chosen for their strength, adaptability, and proven prowess in the domain of media manipulation. First, let us discuss ffmpeg itself. This versatile workhorse is a command line tool that handles video and audio coding, streaming, and post-production tasks. It supports an extensive array of codecs, file formats, and hardware acceleration options, making it a versatile foundation for our automated video production line. ffmpeg is open source, freely available, and continuously developed by a dedicated community. To ensure seamless integration, we'll be utilizing ffprobe alongside ffmpeg. ffprobe is ffmpeg's utility for analyzing multimedia data, providing vital metadata such as duration, bitrate, and codec information. This tool complements ffmpeg in our quest to forge an efficient video production line. Next, we'll be working with ImageMagick, a powerful suite of tools for creating, editing, and converting bitmap images. We've chosen ImageMagick due to its wide range of image manipulation capabilities, compatibility with numerous formats, and open-source nature. While ffmpeg can handle some image processing tasks, ImageMagick offers additional features that are essential to our production line. Lastly, we'll need a text-to-speech engine for generating audio from scripts. We've selected ffmpeg for its high-quality speech output, cross-platform compatibility, and open-source licensing. While there are other options available, such as Google Text-to-Speech or Amazon Poly, they require proprietary libraries and may incur costs with usage. In this forging, we've opted to prioritize flexibility, adaptability, and cost-effectiveness by choosing open-source tools. While there are paid alternatives that offer superior performance in certain areas, our combination of ffmpeg, ffprobe, ImageMagick, and ffmpeg provides a powerful foundation for automating video production from the command line. With these materials in hand, we can now begin the process of forging our automated video production line. Chapter: The Build the Anvil of Video Production, ffmpeg, is at our disposal. We shall forge a robust workflow to automate the process from command line. Let us commence the build. 1. Gathering the raw materials. First, ensure you have ffmpeg installed on your system. On Ubuntu, this can be done via sudo apt-get install ffmpeg2, preparation of the input files **. Our first video file serves as the foundation. Place it in a convenient location. Let's call it source video, MP4. Similarly, prepare an audio file such as background music, MP3 for overlay, 3. Forge the configuration file *** to automate the process. We create a configuration file, output, ffmpeg, that outlines our desired output and settings, bash ffmpeg I source video, mp4 I background music, mp3 vcodec libs 264 acodec awk ab 128 ks 1920x 1080 vf, format equals YUV 420p. Scale equals 2 720, tremap 0 equals enabled, disabled MOV flags plus fast start output. MP4 This file sets the video and audio codecs, desired resolution, format, scaling settings, audio bitrate, and other parameters. Similarly, prepare an audio file such as background music, MP3 for overlay. 3. The tremap line disables the video track when the audio is muted. 4. Smithing the output *** to execute the build. We use the configuration file to run ffmpeg, bash ffmpeg safe 0f concat I for I in source video, mp4 background music, mp3 output, ffmpeg, echo $pwd/$i, ffmpeg y hide banner logoval error I output, mp4 This command first concatenates the input files in the configuration file, then executes ffmpeg on them, producing our finished product output, mp4. Similarly, prepare an audio file such as background music, mp3 for overlay. 3. The tremap line disables the video track when the audio is muted. 4. 5. Testing the finished product ***. Verify the build by playing the output video, bash vlc output, mp4 6. Encountering errors error 1. Incorrect ffmpeg installation, path shell ffmpeg not found fix. Determine your system's ffmpeg location and update the command accordingly. For example, on Arch Linux, bash ffmpeg version /usr/bin /ffmpeg version 4. 4. 2 Copyright C. 2000-2021, the ffmpeg developers 7. Error 2. Incorrect configuration file format shell could not find the input source video. mp4 fix. Ensure the configuration file is formatted correctly. Each command should be separated by a new line, and quotes are needed to handle spaces in file names. By following this forged workflow, you now possess an automated system to produce polished videos from the command line, minimizing manual labor and maximizing efficiency in your video production process. Chapter Deep Dive. In this tutorial, we forge a robust solution to automate video production using ffmpeg from the command line. Our goal is not merely to wield the hammer and anvil, but to understand the inner workings of each component and why the architecture is designed as it is. The foundation of our construction is ffmpeg, a versatile, open-source tool capable of reading, editing, and writing various multimedia files. Its modular design allows for seamless integration with other tools, making it an ideal choice for automation. The heart of the process lies in the command line interface, CLI, where we combine several ffmpeg functions to achieve our objectives. The input file source is subjected to various transformations, filters, before being output as a new file. The first transformation, often an input filter, prepares the source for processing by setting the correct format and parameters. For example, restimer equals 1 ensures that timestamps are properly synchronized, preventing issues during editing. Next, we apply filters to modify the video or audio content, such as cropping crop or adding watermarks watermark, PNG overlay watermark. These modifications can be chained together using semicolons to create complex transformations. Following the filter stage, we may apply codecs for compression and conversion purposes. Choosing the correct codec is essential for efficient file handling while maintaining quality. For instance, H.264 is widely supported and offers a good balance between size and quality. Finally, we output the transformed video using the vcodec option. The resulting file can then be used as input for subsequent processes or distributed as desired. It's crucial to note that common mistakes include forgetting to specify input and output files. The source and destination must always be present, and improperly configuring filters, which can lead to unintended results or errors. To expand our forge, we may explore alternative tools such as avconv, a ffmpeg fork with a more user-friendly CLI, or custom scripts using ffmpeg libraries for more specialized tasks. With this understanding of the underlying mechanics and the flexibility to adapt to various requirements, your video production pipeline will will be forged to withstand the tests of time and demand. Chapter Stress Test. In the crucible of production, we subject our tools to rigorous testing, ensuring they are capable of withstanding the heat and pressure of real-world scenarios. Today, we forge ffmpeg under the relentless hammer of stress tests. We crafted a scenario mimicking a heavy-duty video production workload. A series of 1080p videos, each lasting an hour, were fed into ffmpeg for conversion to multiple formats simultaneously. The forge was lit, and the trial commenced. The first run revealed a few unexpected cracks. Some conversions stalled midway, causing the entire process to pause. Upon closer examination, it was found that memory management needed improvement. Adjustments were made to allocate more resources to ffmpeg during heavy workloads, ensuring smoother operation. The second run, with its increased heat and pressure, tested these adjustments. The system performed admirably, converting each video seamlessly, without a single stall or pause. Yet even as the forged metal glowed bright under the inferno, we knew there was still room for improvement, for every blacksmith knows that the true test lies in pushing the limits of what can be achieved. Remember, a system unstressed and untested remains but an unrefined lump of ore. Only through stress tests do we ensure our tools are truly forged, capable of withstanding the challenges of video production's fiery frontier. Chapter The Output. In the crucible of command line tools, ffmpeg emerges as a mighty forge for automating video production. When harnessed correctly, it can forge precision and efficiency into your workflow. This system produces output tailored to your needs, measured in files that align with your specifications. Consider the case of a 2-hour video file. With ffmpeg, you could break it down into manageable segments of 10 minutes each, a total of 24 separate files produced. Each segment takes around 3 minutes to process, saving an estimated 9 hours compared to manual cutting. By automating this task, costly human labor is eliminated, freeing resources for other creative endeavors. The output is not merely a replica of the original, rather, it's a refined, manipulated version, trimmed, resized, or encoded according to your design. The result: a production line that hums with efficiency, fueled by ffmpeg and the power of automation. In the crucible of the command line, your mastery of ffmpeg now forges a path towards greater automation in video production. Dive deeper into the anvil's heart, refining scripts to seamlessly merge multiple clips, optimize audio, and craft custom outputs. Let the fire of progress burn bright, apprentice. Your journey continues within the forge.